Chapter 3 Motions of the Earth. As you know that the Earth has two types of motions, namely rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. The axis of the Earth, which is an imaginary line, makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis as you see in the figure 3.2. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth day. This is the daily motion of the Earth. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold at all the time. Life would not have been possible in such extreme conditions. The second motion of the Earth around the Sun in its orbit is called revolution. It takes 365 and 1/4 days, 1 year, to revolve around the Sun. We consider a year as consisting of 365 days only and ignore 6 hours for the sake of convenience. 6 hours saved every year are added to make 1 day, 24 hours over a span of 4 years. The surplus day is added to the month of February. Thus, every 4th year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will be the next leap year be. From the figure 3.3, it is clear that the Earth is going around the Sun in an elliptical orbit. Notice that throughout its orbit, the Earth is inclined in the same direction. A year is usually divided into summer, winter, spring, and autumn seasons. Seasons change due to the change in the position of the Earth around the Sun. Look at figure 3.3. You will see that on 21st June, the northern hemisphere is tilted towards the Sun. The rays of the Sun directly fall on the Tropic of Cancer. As a result, these areas receive more heat. The areas near to the poles receive less heat as the rays of the Sun are slanting. The North Pole is inclined towards the Sun, and the places beyond the Arctic Circle experience continuous daylight for about 6 months. Since a large portion of the northern hemisphere is getting light from the Sun, it is summer in the regions north of the equator. The largest day and the shortest night at these places occur on 21st June. At this time in the southern hemisphere, all these conditions are reversed. It is winter season there. The nights are longer than days. This position of the Earth is called the summer solstice. On 22nd December, the Tropic of Capricorn receives direct rays of the Sun as the South Pole tilts towards it. As the Sun's rays fall vertically on the Tropic of Capricorn, 23.5 degrees south, a large portion of the southern hemisphere gets light. Therefore, it is summer in southern hemisphere with longer days and shorter nights. The reverse happens in the northern hemisphere. This position of the earth is called the Winter Solstice. Do you know that Christmas is celebrated in Australia in the summer season? On 21st March and September 23rd, direct rays of sun fall on the equator. At this position, neither of the poles is tilted towards the sun. So, the whole earth experiences equal days and equal nights. It is called an equinox. On 23rd September, it is autumn season in the northern hemisphere and spring season in the southern hemisphere. The opposite is the case on 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus you find that there are days and nights and changes in the seasons because of the rotation and revolution of the earth respectively.